Please, if you have finished your tea break, you can come down now. Let's keep the networking and gisting for another session. The lead instructor is ready for the next segment of this training. So please let us come down and take our seats. So we will begin. Okay, it's 10:55 already, which means we are 10 minutes already into the time of this second segment. We will give you another 3 minutes to come down, and once it is 2 minutes to 11, we begin. Or we begin at 11 a.m. prompt. So you have 4 minutes to come down and take your seats. Thank you. All right, it's 11 a.m. So once again, I welcome every one of you, because some persons joined us not too long, to the training workshop organized by the Nigerian Institution of Highways and Transportation Engineers in collaboration with International Road Federations Global on managing road infrastructure assets for sustainability. Before you came in, and some persons who were already at the training, we had just looked at introduction to roadway network components, and that was taken by our lead instructor, Dr. Amin Aknok, who is a professor of construction engineering and management at East Carolina University, North Carolina, USA. And then we just had our coffee and tea break, and now we continue to the second part of the training, which will be dealing on parameters impacting road network conditions, resilience, and sustainability. And I would like us to put our hands together once more again for our lead instructor, who will be taking us through this for 1 hour, Dr. Amin Aknok. Let's put our hands together for him. And let's enjoy the training. Thank you.
Okay, so welcome back. I hope everybody have enjoyed the short and nice break and all the coffee and the treats we had. So welcome back again, and we're gonna proceed with our second lecture. It is regarding the parameters impacting our roadway network conditions. So I consider this to be as two presentations in one, so please follow up with me and pay a lot of attention. I will be a little speedy in here because I'm first presenting some of the major stresses that are facing our roadway network, and then I'll talk about the major causes of these stresses. Then I will present how to form a team to assess our metrics, like risk assessment basically, and try to come up with what we call definitions for vulnerability and resilience for our road network. So talking about, do you hear me clearly, or there is like some, I'm not sure what is the source of this noise, but so first comes, there is a lot of these stresses that could impact the condition of our roadway network. I have taught this class in multiple countries. I've made this training. I spoke with Ministry of Transportation employees, whether talking about my state, North Carolina, or the federal government and Turner Fairbank in McLean, Virginia, in the United States, or through the Ministry of Transportation in Kingdom of Saudi Arabia, or RTA, Road and Transit Authority in Dubai, Ministry of Transportation in Egypt, MOCA, or Ministry of Construction and Housing in Iraq, and Ministry of Transportation in Bahrain. We kind of brainstormed and what are the main problems. And I asked everyone to give me a list of 3. Basically, they came up with a list of 4. These are as what we're gonna see on the board, starting with raveling. So basically, raveling is everywhere across the globe. Basically, it could be a localized or a widespread raveling. Both are happening for the same reason. The only difference is time and level of traffic. Just once raveling starts as localized, give it some time, some more traffic, hot weather, sun rays, and it will start to widespread, so convert from the left-hand side to the right-hand side picture. And we will talk on, I think it's day 3, about how to do whether a proactive maintenance or what we call in the United States preservation to prevent the happening of these problems, or a reactive maintenance or corrective maintenance as they call it on the Middle East to fix the problem after it already starts. So raveling wise, what is it defined as? It is the disintegration of the asphalt road surface. As we know, our road surface, the top layer or the wearing surface, maybe 4 up to 6 inch in some conditions. It is made of roughly 5%, 4 to 6% binder, some air voids, a few percent points of air voids, and the rest is aggregate, whether gap graded or open graded or dense graded, depends on the type of the asphalt that you are using. Now, the asphalt or the binder encases, the 5% binder encases the very high percentage of your aggregates and prevent it from disintegration or to be dislocated. However, with time, with use, with sun rays, UV, with abrasion and friction because of braking forces and the friction with car tires, the asphalt starts to convert from a flexible to be a brittle material, and dislodgement happen for this aggregate, which we call raveling. That could be low, as on the left-hand side, or medium, as on the middle, or high. Now, why do we classify? They are all the same type of a problem. However, if we have low raveling, there is a specific type of preventative maintenance that we will talk about in a couple days. It's called the fog seal, where you basically spread a layer of emulsion, asphalt emulsion, only to protect or to prevent it. If it's medium, then we do slurry seal, which is the same layer of emulsion, but added to it fine sand. Now, if it happened and it reached to high level before treatment, then fog and slurry seal are not going to work, so we do chip seal, where you do slurry seal and then you add a 1/4 inch chip aggregate or coarse aggregate and compact it inside the hot seal, the hot slurry seal, to form what we call the chip seal and fix it. So basically, by definition, all are types, same type of a problem. However, the mitigation or the preventative action depends on what level. That's why we classify into low, medium, and high levels for raveling. Now, causes for raveling, one thing, it's a poor mix design. If the mix is not well designed, if the asphalt content is dropped, the binder content is not adequate, if the temperature of placement is not adequate, you know, that problem happens big time in the United States because of the really cold weather. So sometimes the contractors, they do venture and they start placing the asphalt not on the appropriate temperature. So that's why, you know, actually research, or now there is a major use for what we call the warm mix asphalt. I'm not sure if you use warm mix in Nigeria. It's about 50 degrees less than the hot mix asphalt, and that could fit well with colder temperature. Also, poor compaction by the contractor can result into the raveling effect. Now, if everything is good, still raveling is going to happen, but it will happen after longer period, whether because of the age, you know, everything, our human cells, it ages. Asphalt age. Once it ages, its flexibility is gone, it starts to acquire that rigid or brittle nature, and then the dislodgement of coarse aggregate happen, and then raveling starts. Traffic itself is capable of inducing raveling because of the friction and because of braking forces. Now, what can we do for raveling. Basically, localized repair, if it ever happened, and there was no preventative maintenance, then localized repair. And we will talk also about multiple ways, whether, going all the extent to mill and fill or full depth reclamation or ultra thin bonded layer. There are lots of ways where raveling can be taken care of, or a preventative maintenance, as I just said, as Fox seal for low raveling, slurry seal for medium raveling, and chip seal for heavy raveling. The second comes rutting, and I mentioned about rutting briefly before the break. It's basically a permanent damage that happens due to deformation parallel to the traffic direction. It starts at a smaller, like a fraction of an inch, and it can extend all the way until few inches, and this results into traffic impediment, and it could even go all the way until accident happens. One thing for rutting, it could happen bottom up or top down. Bottom up could be unstable subgrade. That could be because of the nature of the soil that you have, or because of poor compaction done by the contractor. Insufficient sub-base thickness. Now let us agree on one thing. If you apply any vertical pressure on soil, it never goes vertical. It has a tendency to go at an inclination, right? So that inclination makes the area where, or the footprint of the force increases as you go down. The increase on the area or the footprint of where the force is applied means the stress is reduced, because the stress equals what? Force divided by area. The higher the area, the denominator, the smaller the value of the stress. So if your sub-base layer, your base and sub-base are not thick enough, what's going to happen? By the time the pressure of the vehicle is applied or reaches to the subgrade, it is concentrated on a smaller surface area. That smaller surface area will result into a higher value for the stress, thus the subgrade will not be capable of supporting that stress. Now, what can we do either to increase the thickness of the subbase or improve the bearing capacity of the soil by partial replacement, full replacement, or even, right now there is the application of geosynthetics and geogrids. I'm not sure if this is a common technology in Nigeria, the geotextiles or geogrids. Not very common. Uh-huh. Uh-huh.
When we have our regulatory standard as design, we try to specify this correctly. We try to specify the road bay, the top bay, and then the surface. So when you talk about insufficient surface, that was inappropriate design?
Inappropriate design, yes. Yes.
Maybe inappropriate design.
Yes. Yes. Yeah, either inappropriate, or if there is a corruption in supervision and the contractor get away with as smaller. But typically in the US, they're very stringent when it comes to supervision, but design mistakes do happen, unfortunately. So you don't expect this to be a contractor's fault, you expect it to be a designer problem, as you just said. It's a wrong design. So, it's not sufficient. Poor mixed design, this is for top down. Basically, a couple things we have to watch for. One thing is the percentage of the fines should not be that high on the wearing surface mix or the asphalt concrete mix. The reason for that is the bigger the aggregate, or when you use lesser fines and a higher percentage of coarser aggregate, there is a bearing force between the aggregates together. I mean, in the Gulf area, they call this an open grade mix. In the US, we call it SMA, or stone matrix asphalt pavement. I'll talk also about this when we come about different types of designs. SMA, or stone matrix asphalt, is very commonly used in the US, where you add or you increase the percentage of coarse aggregate, regardless of the nominal maximum size you are using, but you increase the percentage of the aggregate that is classified as coarse. So there is a bearing force between the aggregate particles, so not all the stress is conveyed through, you know, softer points within the wearing surface. It is through the bearing of the coarse aggregates on top of each other. Now the downside of this, if you have temperature fluctuation, coarser aggregates tend to expand and contract, so you induce cracking. That is why the essence or the theory of balanced mix evolved. It is, you have to increase the percentage of coarse aggregate to a limit that is good in fighting ruts, but on the same time it's not too much to the point that cracks evolves. Usually you have to balance between the ruts and cracks. That is the meaning of the balanced mix design, which I will present a couple slides on. This is a step further for the super pave mix design in the US to minimize the effect or optimize, hold the stick from the middle, as we say it. So the asphalt stiffness basically stems from the particle size and the property of the gravel. So basically one has to watch for this. Again, we're having a session tomorrow. An introduction after lunch today will be about this session for the super pave. Then my colleague from Ghana will be presenting early morning tomorrow about super pave mix, and he will explain in detail about this. I have also a few slides about how the overall stiffness of the asphalt is being impacted by the gradation of the asphalt. Also, gradation of the aggregate. Also, the percentage of the asphalt binder within the wearing surface. Now, how to fix rutting? Unfortunately, once rutting starts, it's a never-ending story. It starts at a fraction of an inch. Again, it happens in the longitudinal direction, parallel to traffic. But once it starts, it will proceed, whether it's because of bottom up or top down. So to fix this, if it is bottom up, then you have to come up with a solution for the weaker capacity. Some countries, I have to mention this, in Iraq, they figured out that shifting from flexible to rigid pavement is going to help with this problem. Anybody knows why? Why would rigid pavement help with bottom-up rutting? So smart. Yes. The higher rigidity of the surface, it makes it exactly act as a beam. So basically, you are creating a surface between your subgrade that receives the stress and the vehicle loading, the tire footprint, right? So instead of applying the tire footprint like this through the wearing surface, then the base, sub-base to straight to the sub-grade, you are having a load applied on the beam, then it is acting on a huge footprint. It's almost a portion of the slab of the rigid pavement between the two joints. So you are applying the stress on a mega size area or footprint. So the subgrade is feeling minimal impact because of the heavy truck loading in Iraq, because they failed to convince the truckers that they have to abide. They are now getting all weight stations and they are making fines and penalties, but still people find a way to kind of dodge this bullet and still triple and even quadruple the loading. So still the bottom-up rutting is happening no matter how good they compacted the ground, because basically it's insane type of loading. So they ended up removing the flexible pavement and putting layers of rigid pavement, including RCC, the roller compacted concrete. I'm not sure if It is common here in Nigeria, or it is known, where you do a zero slump concrete and you compact it by rollers as if it's asphalt. So this is another way of fighting the bottom-up rutting. Now, will be done on? It is ongoing. Is this a corridor with heavy traffic? Okay. Is it rigid Portland cement concrete or roller compacted? Heavily reinforced. Yeah, you know, probably I can talk to you after this, because right now in the US, to avoid the problem of heavy reinforcement, they use the rigid roller compacted. Roller compacted, you can even eliminate the steel altogether. The reason is, well, first it's a little thicker. It's about 25 centimeters, 10 to 12 inches, so roughly 30 centimeters. Slump is 0. Voids are very limited. The use of coarse aggregate is very, very limited, so you don't have the problem of expansion and contraction, so you don't need any shrinkage reinforcement. And because of the high strengths, you literally do not have any rotting problem under this roller compacted concrete. They're using this as a new trend in airports and in harbors, where they bring down cargo from ships, and you have forklifts and, you know, carrying containers. All this are roller compacted concrete right now in the United States. Cost-wise, there is about 30% extra at the beginning. But if you look at the life cycle cost, it's much cheaper. It lives longer. You don't have any cracking because of expansion and contraction. Rotting is almost not existing. So basically, you spend like 30% upfront, or even 35% upfront, but then you live longer and you have almost zero maintenance. So you end up, especially when you're under, the geotechnical conditions are not good. That is the optimum solution right now. Actually, if you Google my name, because the state of North Carolina, we didn't have specifications for roller compacted concrete until 2023. So they they made a competition, and I was awarded this to develop the specifications for the state. And I developed it. Now it's on the website. So if you just write my name on Google, it will pull that report. It's a very heavy report about all advantages, disadvantages, mixed designs for RCC. So that can benefit Nigeria very much. It's a very fresh, it was just made less than 2 years ago. Better pavement? You mean? I will talk about it tomorrow, after tomorrow. And I have a presentation about roller compacted concrete, but the specs itself is available online if you are willing to see that. Now, to fix the rotting, first clearing the section, getting rid of the debris and the damage assessment. Now, if it is minor rotting, patching or filling could be more than enough. For deeper rotting, basically it is resurfacing. Now, keep in mind one thing. Oops, sorry. If the rotting has happened as a bottom up, fixing the top layer will never be the solution. It will work for a few months, and then it will happen again, because basically you are treating the outcomes, the syndromes, right? But the main cause of the problem is still there. Whether loads are high, subgrade capacity is poor, compaction is little. So there is a new technology here. Well, either you can do like reconstruction, or there is something called the FDR. I'm not sure if it is done in Nigeria, full depth reclamation. Yeah. Okay. So
We started it. It was okay. It was fine.
you used it where?
On the road, Mukwa Tegina Road.
Okay.
Full debt reclamation is an aspect of asphalt recycling.
It is recycling, and it's a fortification for the sub base and the
Yes,
subgrade.
fortification for the sub base and stuff.
Yeah, you have the equipment for FDR here in Nigeria, or?
Oh, yes, the contractor has it. It was Bruni Bruno. that had it,
Excellent, excellent. Basically,
Reclaimer 2500.
perfect. So basically, the idea here, instead of milling and resurfacing, you just break and you remix whatever you broke from the wearing surface. You mix it with your base and sub-base. You can basically create a new layer with the sub-base and base that you have added to it a lot of the asphalt. So you are fortifying this layer. Then you can do a layer of chip seal on top to be your new wearing surface, or you can do a new wearing surface if you have no height restriction, like a 2 or 3 or even 4 inch, as if it's a new project, on top of an existing layer of base and sub-base that includes the former asphalt layer. So this is what we call the full depth reclamation. I mean, this is a new technology. Again, it happens so fast. It is very green because basically you are not throwing away the older asphalt. You are 100% reclaiming. It's full depth reclamation. You are 100% reclaiming your older asphalt. So this is, I mean, the British people, I was in Liverpool recently in a conference. I was surprised that they almost go straight to FDR. Like in the US, it's not the #1 technology. In the UK, it is the #1 technology right now when it comes to bottom-up rotting treatment. After this comes cracking, which is the other opposite or the other extreme compared to ruts. As we said, if you have too much fines, rotting happens. Here, if you have too much fines, cracking are happy. But if you have coarser aggregate and too much voids, cracking is gonna happen. Coarser aggregate, it has the tendency to expand and contract with temperature. So it is very bad when it comes to cracks, very good when it comes to ruts. Same, when you increase the percentage of the binder, it is very good for cracks, very poor for the rotting. So alligator cracks, usually it happens as an intersection of transverse and longitudinal cracks, and then a lots of like as you see, the top left a crack starts, then the top right it propagates in different directions, then the bottom right alligator cracks. They call it alligator because it looks like the skin of the American crocodile. And then if untreated, whether high water level or freeze thaw or frost heave or continuous traffic, and the dynamic impact would result into popping portions of this alligator cracks to come up with what we call the pot holes. Okay? So this is the first part of the presentation. I hope I'm trying to monitor the time as I go. So this, the main part, whether talking about bottom-up ruts or top-down ruts or any type of cracks, including alligator cracks or potholes and or raveling at any level, low, medium, and high raveling, these are what we consider the 4 main enemies for any roadway network. And here I'm specifically talking about asphalt or flexible pavement or asphalt concrete pavement. So in order to minimize the risk or mitigate the risk, we have to first go through the steps that are available on the board. I cannot see honestly clearly, but you know, we have, you know, can you guys read step 1 through step 6? It is how to.
Okay, step 1, apply a climate and ecosystem lens.
Yeah. Thank you for reading, but I mean, you guys can read. I know the steps, but can. Excellent. Yeah, because from my side it's very blurry when I look at an angle, so I was not sure if it is clear from your side. So number one, we have to have the echo length. Basically, as the engineer here was saying, even about the performance grades, PG, you said that you already made a mapping for the temperature, and my reply was, once you get that, that's the first step towards success, any success. Whether you are trying to think about the problem for the asphalt, or developing a new mix design, or implementing a new mix design theory, whether it's a super pave or balanced mix design. After we do the mapping for the temperature, we have to come up with step 2, which is basically to define or identify the vulnerabilities. Now, what is the term vulnerable? If I mention vulnerable and resilient, can somebody tell me how do you translate this in your mind? Because they are the, I would say, the new kids on the block when we deal with codes. Perfect. Okay, thank you. That's a very brief and a very concise definition. I would try to go fast forward a little bit. Yeah, oops. Yeah, look at this on the board. You have capacity. This capacity could be a capacity of a girder, bridge girder, capacity of your asphalt pavement, any capacity for any structural system. It could be even the foundation under your house. It could be the beam on the roof, right? A given structural or serviceability capacity for a built environment that we create. Then comes to the right the loading. This loading could be the dead loads, the weight of the structure itself. It could be live loads. It could be the vehicles. It could be braking forces. It could be environmental loading, freeze, thaw, expansion, contraction, rain, any type of stressor acting on your structure. And then, you know, if the load to the right you see is greater than the capacity, that is where we call your structure or your project is vulnerable. You know, supposedly it will end up failing. Now, if the load is to the left, much smaller, then that difference could fall under resilience or more or less safety factor. Okay? Oops. Now let's go back. So after we do the mapping and after we define the areas for vulnerability, then comes the adaptation techniques. That is number 3, based on our conditions, based on the available budget, based on the available material. Then you come up with the strategies which could be used to kind of mitigate the impact of the loading or the environmental stressors on your project. After this, you do prioritization. We will talk about prioritization when we talk about pavement management systems or bridge management system or asset management systems in general. By the way, do you adopt in Nigeria asset management like ash to wear, or you don't do this? Like for, but do you know the concept of bridge management or pavement management system in general? Okay, so it's basically, it's a tool that try to use specific algorithms to develop a maintenance or preservation plan for a humongous inventory. You know, like again in the US, when you talk about 623,000 bridges, how on earth would you be able to tell which bridge you start first in maintaining, or what location in the country? So you have to use, it's a mix of machine learning algorithms and artificial intelligence and regular as easy as Excel spreadsheets to come up with a way to prioritize your maintenance so you use the limited budget in the best possible scenario, okay? So this is step number 4. Step number 5 comes the implementation, and then step number 6 is you evaluate, and then here you go. This is the cycle we have to go through. Now on the assessment approaches, I have included here some of the organizations under which these global policies are being adopted. So in the US, that's what we go with, FHWA, the Federal Highway Administration. In Canada, PIEVC. There is also the USFS in the United States. In Europe, they have the RODAPT. In Africa, there is a RECAP. I'm not sure where. I know in South Africa, they use the RECAP. Not in Nigeria? Okay. So basically, the first step here again is to create a database. Whether the database for inventory you have, the type of projects, like that's why when I presented the earlier presentation early in the morning, today the first questions I asked, what is the road network? What is the size? How much of the roads are made of asphalt? How much or how many kilometers are made of concrete? And then how many bridges do you have? I have to give the West or the United States a huge credit. There is, if you go or Google the NBI, National Bridge Inventory in the United States, or the US NBI, it will spell out a mega spreadsheet basically that tells you every piece of information about every single bridge in the United States. 623,000 bridges. It will tell you spans, structural system, material of construction, when it was constructed, every detail, thicknesses of bridge decks, the type of pavement, type of guardrails, structural system, the type of maintenance and preservation since it was constructed until today. So basically, same on roadways. These things are, because of adopting BMS and PMS, pavement management system and bridge management system, and they do have reporting procedures and even inspection procedures. Like right now, the NBIS, the National Bridge Inspection Standards, what they do have, they tell you what exactly you need to inspect, and right now, it's every 2 years, every 24 months. You have to revisit all the bridges, with some exceptions like specific non-redundant bridges or bridges prone to failure, or specific types like Golden Gate Bridge per se in California, because of the hazard, the type of vehicles, huge vehicle they can do it every 12 months as an exception. And then that has to be reported and updated, like in the cycle of the previous sheet, so that at any minute during the lifespan of the bridge for 100 years, by a click of a button, you can get the whole history of the bridge. And then after, do you have a question?
So for this, just an additional information. For Nigeria, we have the NIHTE teams for the rural road infrastructure for assessing it. It's the Nigerian Rural Infrastructure Management System.
Okay.
NIHTE teams for rural infrastructure.
For road infrastructure.
Yes.
And do you?
Yes, rural roads, yes.
Rural roads.
Yes.
Okay, but do you use this as a database, or you use it in also prioritizing maintenance?
Yes, it's used for prioritization,
Okay.
for interventions.
Okay, excellent.
Yes.
But why are you doing this only for rural roads, not for the rest? Because if you have the rural roads, it's harder to do it. If you can do it for the rural roads, why don't you generalize this, and it will save a lot of time and effort and money. Okay, so keep in mind that the key steps in assessment are the 4 ones stated on the board, starting by the scope and planning and then the gathering for the data. And we will have a standalone presentation about how to do data collection and about advanced monitoring and inspection techniques. I will be talking about ultrasounds, I'll be talking about ground penetrating radars, LiDARs, the use of UAVs, drones, or robotics in capturing data, and then conducting the assessment, and finally the reporting. Again, on the assessment process, the most important one is the asset inventory, which I'm glad you have here in Nigeria for the rural roads. I hope it can be expanded to all the roads. I hope it can be included, it can include the bridges as well. Then assets at risk are to be defined. Interdisciplinary team has to be formed. Then the data and the history has to be collected and added to the system. And then, finally, it's the risk assessment and vulnerability are to be conducted and ranked, and then prioritized maintenance are to be done. Now, I've been talking about big words like vulnerability, risk, etc. So let's define or see how we can add the risk into the matrix of assessment. So by definition, risk is the severity of a problem multiply the probability of the problem. P multiply S. Keep in mind, you can have severe risk, let's say from earthquake of 9-degree Richters, right? Or 8 point. But what's the probability of happening? Almost 0, right? So when you define risk so that you can take precautionary steps, you have to consider how severe this risk is. Also, what is the chances you can have this risk happening during the lifespan of your project. So this is a matrix for risk assessment. So probability wise for the risk or for the damage based on the risk. Is it unlikely? It's like the first column, or possible, or likely, or very likely. Then the magnitude of the risk. Now, what do I mean by risk? It could be wind, it could be tsunami, it could be earthquake, it could be wildlife fire, it could be sinkholes on the ground, earthquakes, volcanoes, tornadoes, anything. Major, moderate, or minor. So a combination of the major, moderate, and minor with very likely, likely, possible, and unlikely would generate this matrix as a very high risk all the way until a very low risk. Now, why do we keep this in mind? As I mentioned, when we define the ASCE, when they define your quality of the inventory, as give it A or B or C or D or F, they have to consider the resilience and the vulnerability. So basically they have to account for factor that could result in damage. Now, did this damage happen? No, it did not, but they are talking about probability of happening. So in order to quantify something that didn't happen, they have to give it this assessment. How likely will it happen? And if it happened, how big or how small is its impact? And that leads us to this slide which I showed earlier. Given, the impact, again, the load here could be extreme temperature, could be a tornado, tsunami, earthquake, volcano, could be anything. Now, the chances of having the load higher than the capacity, this is how vulnerable your structure is. Now, the chances that your capacity will be higher than your load, that is what we consider the resilience. So again, you already control the capacity. This is under your control. You are the one who designed the bridge. You are the one who designed the pavement. You're the one who picked the material. Should I do it flexible or rigid? If it is rigid, would it be Portland concrete or roller compacted concrete? What gradation of the aggregate? What percentage of the binder? How thick is your sub-base and base? How much compaction? Would I do 95% compaction or 100% compaction for my subgrade? All this you control. That results into the capacity. Then based on your studies and including the environmental parameters, you can define that red one, and then here you can possibly come up with how vulnerable or how resilient your project is. Now, to identify the risk, always keep in mind that you do have your component, and then you do a structural component, and then you have your climate parameter. If you don't have an interaction, there is no risk, right? The problem that you have is where you have an interaction between the parameters acting on your project and the stressors. Interaction between your project or the component of your project, your roadway or your bridge deck or your bridge girder, with the type of stressor you are considering, which here I'm calling the climate parameter. So the plan or the roadmap to fix everything or to mitigate. Remember, you are trying to fight an enemy that you cannot see. Right? We're not here talking about general situations. When you talk about vulnerability and resilience, these are parameters that you are trying to assess, you are trying to evaluate, and you are trying to mitigate the chances of what they're going to impact, what they're going to do to my project. So first thing is, again, project scope and planning. What is the type of the infrastructure I'm talking about? And again, you can classify according to the type, you can classify according to the area, you can classify according to site, however you want to do, or the parameters you are, or the criteria you are using for your classification. Second thing, formation of interdisciplinary team. Remember, the problem is not only a materials problem, to have a structural engineer or a materials engineer. In the US, when we do this study, you have to consider having geologists in your team. You have to consider those working on the weather forecast. Sometimes we have to have chemists because of the possible chemical reaction on the long term. So there is maybe mechanical people for fatigue. So it's a multiple or a multidisciplinary or interdisciplinary team that has to be considered. Then data collection, and we'll have a session on this, starting from the structural or the infrastructure data, loading data, climate data. In the United States, we have several thousand, if I remember right, there are 5,000 point for data collection that is only working for the environment, whether to monitor the weather, the temperature up and down, or maximum and minimum, dew point, humidity, sunrise, sunset, amount of rain, percentage of snowfall, thickness of snow anticipated to fall, etc. Then, you can think of what to include. Now, I'm here using an example of LVRs, like low volume road. And why do I include the low volume road? They are the most vulnerable highways or roadways in the United States. The reason for this is the money that you use in maintenance or new construction or rehab, it comes from two sources. Number one is gas tax. I'm not sure if you have the same thing in Nigeria, but in the United States, they generate money from the gas tax. Every gallon of gas you put in your car, there is a tax that goes straight to the government to be used in road maintenance. Number two, toll stations, the tolls on the highways. These are the state funding. Of course, there is federal appropriation money that comes from the federal government to every state. However, from the state, it is the gas tax and the toll. Think about low volume roads. where you have a couple hundred or 1,000 car per day, how much gas tax you develop? Nothing. What is the toll? Actually, you don't construct tolls in low volume roads. So the funding is very limited. So unfortunately, they end up with dumbing, they lower the level, whether it's the specs for construction. You know, at some states, it's still dusty. Or they compact the dust and they have a layer of chip seal. So they don't have a sub-base and base. It's not pavement by the definition of pavement. You have a question?
I just been wondering with the emphasis on electric cars, how is it going to affect the revenue from gas cars? Electric cars.
Electric?
Imagine a state that has gone, is emphasizing electric cars and effectively over 90% electric cars. So what do you now get the money for?
That's a very, a very smart question, and honestly, I don't have an answer because I'm not into the lawmaking, but I attended a few conferences where they had this discussion. They are thinking about, you know, or the answer that you get from those defending the concept of electric cars is using electric cars, you will not need the same amount of money to mitigate the impact of other type cars on the environment. So this money you can save from the environment, you can you know, again, this is a serious discussion that you just mentioned, and honestly, this is one of the answers that was raised. It is like you will not have a lot of the damage to the environment, so this money would change from fixing the impact of the gas cars, give it to the maintenance of the highways. Again, it's a very political answer, but I'm not sure. So back to our point when we talk about LVR. So you have again to define what are the most important stressors. So one thing is precipitation. Because of, you know, how weak your cross section is, you have a lot of sinkholes, you have erosion on the section because of the rains, then the temperature, then storm surge. All this are very common problems that you have to collect for your LVR. Then you conduct your assessment. Basically, that chart for the risk, the probability multiplies the severity, has to be conducted, and then they have to make the reporting, and based on this type of reporting, they can define what is the next step, what kind of capital expenditure is needed, what type of safety and environmental concerns should we have. Then, as the engineer here said, the design and regulatory needs. Maybe implementing electric cars, you have to do some sort of regulatory changes. So keep in mind the top one, which defines the severity, multiply the probability, how low or how high the risk is, and the bottom one, which basically tells you the current or baseline versus the future problems you would anticipate to happen. Both has to be merged together so that you can come up with the right decision in the right amount of time. I'm here including a statement how to take advantage of this presentation. It's not me, it's made by some of the consultants that are working in the US to identify risks, vulnerability, and resilience for the roadway and the road network in the United States. I'm also including here some references if you really would like to read further about this topic. Some of the very good publications in the United States, Canada, and Europe about the specs, about the standards applied, and some very good reads about research on roadway vulnerability and resilience. I really advise everybody to consider if on your free time to go through these and do extra readings as well. Some of the research papers I'm also suggesting you to consider. Toward the end of the training, I'll try to make like a Dropbox folder and send it so that everybody can receive it, and on your free time you can Google and make sure you go through this. It's very good resources that would really impact your career as civil engineers. I think I made it in time again. Well, we have 5 minutes actually. So, any questions? Yes, sir.
Hello. So I was trying to say that the emphasis has been on environment and traffic, but I'm thinking that including sociability of the people using the facilities, you know,
Great.
data concerning them, like the population growth rate, like the land use, could also be data that will be necessary for us to be able to do a proper mapping of the area for us to be able to do a quality work. Thank you.
That's a very good point you just raised, and there is a huge debate ongoing. Actually, what you said is extremely important because of social norms and how the people would, even how they abide with the regulations. I 100% agree to you. The only problem here is, as I just mentioned on the previous presentation before the break, you have to create a unified system when you do your evaluations. And in order, it's like compare apples to apples, right? So how easy or how hard would it be to evaluate these norms? It's how to come up with a number. Like how would you fit it? Like, when you talk about environmental problem, you can think of maximum temperature, minimum temperature, temperature variation, amount of rainfall, right? The probability of rainfall. But then when you talk about social norms, how would you put this in numbers, especially when you talk about the systems to manage this, whether talking about artificial intelligence, machine learning algorithms, or computer modeling, bridge management system, pavement management system. Everything is computerized. Computers does not understand, so it has to be numbers. It has to be a probability. You see what I'm saying? Like, just one step further, there is what we call life cycle cost analysis, LCCA. Right now, there are organizations in the US, they are trying to cut down one of the C's, and they call it life cycle analysis. Do not put cost. Why? Because they are telling you, how about if you have a more expensive option, but it's better for the environment? Should you trade the environment for money? Of course not. Then now it's life cycle analysis, not life cycle cost analysis, because cost is not the only parameter. But then the people defending the life cycle cost analysis would come back and tell you, okay, we agree. However, how would you assess the environmental damage? Because the environmental damage could be that little, could be that huge. So let's think about it. How many people gonna be ill? Okay, so how many people gonna be ill versus what? So, well, then the medical expenses for treating these people, oh, then you're back to cost. You see how the cycle is? You have to find a unit of comparison. Unfortunately, the easiest thing is the US dollar, numbers, the pavement condition index in numbers. percentage of rainfall in numbers. You see? So that's why I totally agree. If you talk to me personally, 100% social norms has to be considered, but how to quantify? You had a question?
Yeah, sorry. My question is on
Oh, sorry.
the causes of rotting.
Uh-huh.
And you mentioned insufficient sub-base thickness.
Okay.
And then for us, you know, talking about where I work, rotting, you know, it's been a major challenge for us. And then we know from the way our roads are designed, you know, the sub-base is 150 mm, the base course is 150 mm, then the surfacing oftentimes is 100 mm, 60 for the binder course, and then 40 for the wearing. But recently there's a debate on the need to cut down the cost. After doing an analysis and discovered that the cost per kilometer, it's way very high. How do we bring down the cost per kilometer of our roads? And then the debate is, if you have a subgrade that is geotechnically okay, well prepared, well compacted, then probably you need lesser thickness of subbase.
Correct.
And lesser thickness of base cost.
Correct.
At the end, probably you cut down the cost per kilometer. And now you are telling us insufficient subbase thickness. That how do you marry these two?
Okay. I see your point. Now, think about it this way. If you have a subgrade that, let's say, is not strong enough, because you made a statement which I totally agree to, which is get a better subgrade or have a higher subgrade compaction. But this is in itself a cost, right? What if you don't have enough efficiency on your or bearing capacity? So you'd end up doing partial replacement, that's a cost, or full replacement, that's a cost, compaction, that's a cost. You see? So the statement I made means if you have a subgrade at a given condition, right? Without messing with the subgrade, it's a very general thing that the thicker the subbase and base, the better off your subgrade is going to be. Now, you will spend money? Yes, you will spend money. But if you save this money and make a finer, then you have to spend this money you saved on improving the subgrade, or use geotextiles as well. So now I was in Turner Fairbanks last Thursday. They are trying to do what they call the invert, and I have a picture, I can show it to you, of invert asphalt, where they do basically cement stabilization for the layers below the wearing surface. So basically they are trying to create a subbase and a base that are stronger than the wearing surface. Is this a cost? Yes, it is a cost. However, down the road you almost kill the chances of having any rotting. So you pay up front, but then you save it down the road by having no rotting. So you have no need for full depth reclamation or. So basically it's when money will be spent, but should you spend it on the subbase or the base in the thickness, or on the subgrade in compaction and replacement, or on the base and subbase by reinforcement and creating an inverted roadway. I fully understand your point, but at the end of the day, we're facing a problem. You have to fix it somehow, either by increasing the thickness or by improving the subgrade. Because the only other alternative is tell the people don't drive or don't have heavy vehicle, which is impossible to have, unfortunately. So you take the lesser of two evils. Any questions? Okay, thank you so much.
Please, once more, can we put our hands together for Dr. Amin Aknok for that wonderful presentation. So once again, I'll quickly take you through the programs we've had. We started since 9 a.m. and we've had introduction to roadway network components. Then we had tea break, and just ended was parameters impacting road network conditions, resilience, and sustainability. Ladies and gentlemen, now we shall go into the opening ceremony for this training workshop. I want to believe that you are having fun, and so far it will get interesting. It's going to be 4 days in addressing this theme. Thank you very much. So can we please be upstanding as we begin these events with the national anthem and then the opening prayer.